Okay, so overall, we wanted to make a collaborative two-person game. That one person could be on like using the pick, and the other person could be over Zoom. They could be on in like a VR world. So we wanted to kind of like take advantage of like Zoom and like the fact that you can't actually like be together. So we wanted to make like a game that would be really interesting between two people who are like physically separated. So the first aspect is the person on the pick. The person on the pick just has access to the TFT screen, and the TFT screen will display like an overhead view of a maze. And the person who's in the VR is going to be inside that maze, but they won't be able to. Oh yeah, I think this might have fallen apart a little bit.
Yeah, keep going though. Keep going.
Okay. But the person in the VR headset will be inside of a maze, but they won't have any idea where they've started or what orientation they're in. So the first step that the people have to do is they have to figure out together, based on the limited information that they each have, is figure out where in the maze they are, like where they're situated, where they're oriented, and then from there, the person on the pick needs to guide the VR person to an endpoint that's indicated on the pick of the maze. So the communication ended up being a little bit of a mess. So right now the pick communicates on like the MP lab through serial to a Python script, and then the Python script communicates with a GitHub because the like SCP thing didn't really end up working out. So that pushes and pulls from a GitHub, and then Unity also pushes and pulls to grab that information. To be able to like figure out like how or like what the like layout of the maze is and like what the player is doing. We ended up having a lot of issues with like it wasn't really able to be as like real time as we were hoping. The full process, as you'll probably end up seeing later in this video, ends up taking about 30 seconds between the player indicating in the VR that they want to start the game to the maze actually being generated. So we chose to have a lot of like basically all the setup stuff happen in the pick. So that will run this code called Prim's algorithm to be able to generate a randomly generated maze that's like technically perfect. So you can access any point of a maze from any other point in the maze. So that way we wouldn't really end up with like accidentally creating like an endpoint in like a closed off loop or something like that. Yeah, is there anything else that you guys want to add?
I don't think so. I think that the GitHub thing pretty much sums it up for our communication, like you said.
Yeah, and it strikes me as one of these things too that will become very clear as we see it in action.
Yeah. We'll try to show it off at every step of the way.
And I just want to ask so the communication path from the pick ultimately to Cameron's Cameron's laptop that's running Unity. Part of the reason for the convolutedness of that, I believe, is to get around some sort of security questions here at Cornell, like you've limited access to these PCs, so you go to Git and then you pull from Git, and that's safe from an IT perspective and allows for you to get what you need, I believe.
Yeah,
exactly. Okay. It's a nice intermediary.
Okay. Cool.
Okay, I'm gonna quickly, just to make sure that our pick isn't having any serial problems, I'm gonna open a putty shell, because I found that through experimentation I can force it to communicate properly if I just open a shell and then close it.
It's very scientific.
Okay.
It's obscure. Okay. You mean instead of having me like unplug and replug it?
Yeah, for some reason that works. Like sometimes it'll like the GitHub will go through and then it'll get to the part where it needs to get the information from the pick and it will just stop. But if I like do that putty thing, it doesn't stop.
Boy, I need to think about that. Okay.
Okay. So then for our let me open up. Do you guys want to see our Python code? Or should we just get right into the
let's get into the demo, I suppose.
Okay. In that case, I'm going to run on the lab computer, I'm going to run this Python script, which hasn't been renamed, but still works. And then that will start, and it will start checking the GitHub. And then I will move this to the bottom left.
Why don't we re-download to the pick the code? Because sometimes I think it's kind of fuzzy about that too.
I think it should be fine though. I found that it's Okay. Okay, I'm gonna pray that that isn't frozen. I don't have to log in again, and I'm gonna pull up the other windows. Okay, so here's the Unity editor where we can see our starting area. And then here's my Windows terminal. Oops. I'm gonna run this command or this Python script over here on my local machine. And then I'm gonna try to find the couch and put the keyboard on it. Okay, and luckily, I think
Being a little freezy.
Yeah, the remote desktop is frozen, so I'm gonna have to close it and log back in.
No worries.
So on the left in the Windows terminal, you can see that it's constantly reporting none and already up to date. The already up to date is from the pulls, trying to pull from the two repos that we have set up. The none is the current command that is being sent to the PIC.
Okay.
So none means nothing, and you'll see it change to make maze as we go through the demo. Okay. All right, there's so the PIC already has a maze on it just from when we have been doing our testing.
Yeah, once we send the command, it will recreate a new randomized maze.
Yes.
Okay, so let me just clarify. Let me just make sure I understand the windows. So the right side of the screen shows the remote desktop view of the lab PC that's sitting down the hall. And
Yes.
we're seeing an image of the PIC32, and the TFT screen is showing a maze that the PIC has generated in the lab over there.
Yes.
And then on the left side of the screen is a screen share from Cameron's local laptop, which is showing a VR world in Unity.
Yes.
Okay. Okay.
Okay. So now I'm gonna press play over here, and in VR, this should put me into the our world once it is finished doing whatever it's doing, loading.
So this is going to build a virtual maze that is identical to the one that's shown on the TFT display, and then you'll be able to walk through that maze.
Not immediately. First, it's going to bring me to the starting room.
Okay.
Can you guys hear the music?
Oh no, I don't think you shared the audio with it.
Oh, I thought I did.
No,
check.
the music is the best part.
I am sharing audio.
Yep.
Let me try again. Oops, I pressed optimize for video share. Can you hear it now?
Oh, I can.
Faintly. Yes. Yes. Faintly.
Okay, cool. So this is our sort of starting area. We have some items on the shelves here. And then we have this button over here, which will generate the maze. So, and we have some status lights. So I'm gonna come over here. I'm going to push the button. And then once I push the button, we should see that this script will change the command to make maze. And then it will push the command to the GitHub.
Why did the screen just turn really green?
Turn green? Which side?
Is that me? Is that just on my...
The whole thing's green.
I think that's just you. And then you can see over here that it's pulled the command.
Wait, is there any way you could unshare and reshare? I think something happened to the screen share here.
Is it green for everyone?
It's very green. Yeah.
Oh, that's awkward. Sorry, let me reshare. Is that better?
Yeah.
Oh,
Yes. Yes. That looks great.
Okay.
What in the world?
So then you can see that the over here we've gotten the command,
Oh, it's
and then
green
it
again.
should send one back like this. Right. So there's the JSON popped up. And then on this side of things, we should see it. There we go. So it's gotten the command back. So this the command has been reset to none, and the maze JSON has been pulled.
Okay.
Wait,
Now
I
the door
think
opens in
things
VR.
all green again.
That's all green again.
So I've never seen this
I
happen.
think it's because I've done something with the. I'm gonna unoptimize screen sharing for video.
Oh yeah, let me check that.
Okay.
Okay.
So you can see the elevator door has opened and the
Yeah.
maze is generated. So now for the maze, we need the orb and this picture.
Hey, careful with that.
And I think if you look at the TFT, the maze has changed.
Yeah, it's a
Yeah.
Okay, yes, it has, yeah.
Okay.
And
so
the
then-
red is indicating your goal and
Yes, the goal.
location.
And
Okay.
we're not sure where we are. So I press this button to descend in the elevator.
I'm so proud of these audio clips.
Oh. Okay. And then we're in the first room.
So we're in the
So-
maze. We don't know
yes.
where we are.
We have no idea where we are, but we know that there's 4 doors in this room, which is not really helpful. So the idea behind the game is that one person will be exploring the VR maze while anyone else is looking at the TFT and trying to figure out where you are. So there can only be so many rooms that have 4 doors. So does this narrow it down at all as to where we are?
Yeah, it actually does help a decent amount.
I think I
Okay,
see
so
3 that fit.
Okay, so
which way should I go?
so one player has global knowledge of the whole maze layout, and the other player with the VR set on doesn't have that global knowledge, but has local knowledge of number of doors and such, so
Yes.
that together
Yeah.
you can combine those things to narrow down where you must be. And then,
Yes.
okay,
In the actual gameplay, like we'd have these on separate screens, but just for demo purposes. You can try to
Yeah.
guess.
So is there
I
any
think
door I
the-
should try?
Wait, do we have the photo of Hunter?
Hunter?
Leave that as our marker.
No, I think I forgot it in the elevator,
Oh no.
Oh,
which has disappeared.
that's okay.
okay. Just pick any door.
Okay, I'm gonna go this way.
Cameron and I tried this the other day, and we found out that like figuring out your orientation
This is pretty hard.
sometimes-
Okay, so now there's a blank wall.
Too late.
So I have 3 doors. There's one in front of me, to the left of me, and behind me. And then the right wall is a dead end or a
Wait,
blank.
keep
He
going.
could
straight.
be at, yeah, like straight could be a dead end
Yeah.
if he's where I think he is.
There's sound effects.
Yes,
with
this
the
is a
door.
dead
Oh,
end.
we've done it. Okay,
Nailed it. Okay.
go back.
Okay, so now we know where we are in the maze, or they know where I am in the maze. So which way should I go?
All right. Yeah, you gotta go back out, and then you're gonna take a left.
No, isn't that a right?
My left?
Oh wait, no. Yeah, you're right. That's a right.
Yeah.
You're right. So for reference right now, I think he's in this top right part of the maze, that little dead end that's like
Yes, okay.
1 from the left and 2
Yeah.
down. All right, wait, okay.
So
So
you
keep
took the
going
right and then
straight.
go forward.
I
Yeah.
can only go forwards.
And then you should only be able to go right after that.
Yep.
Oh,
Oh
we've done
my
it.
Wait, this is so much faster than we did it the other day.
Then go left.
This is a pretty good maze, I guess, for the demo.
We're just
Left?
really good at it.
Left, yeah.
I think starting on the 4-door area is good. Last time we were in a bunch of like 3 and 2-door areas. Yeah, I guess you gotta take that right.
Okay.
Last time, if you have a bunch of 3 and 2-door areas, it gets
And then
really
left.
hard to figure out where you are.
So 1 and 4 are probably easier.
Yeah.
Yeah.
Is this the end then?
This is the end.
Okay, so if you're at the end and you pull the trigger on the controller with the orb in your hand, it turns blue, indicating that you've won.
Wow.
And if you're incorrect, right? So if I go back to a previous room that isn't the end, and so pulling the trigger is like guessing, right? Because we don't want you to just say you've won, because you could stumble into the end room by accident. You have to
Right.
figure it out. And if you're wrong, the orb turns red. And every time you're wrong, the orb will dim slightly. You can see the light on the
Okay.
walls is getting dimmer and dimmer, and now I'm in complete darkness with this red orb.
Which disincentivizes just guessing. You
Yeah.
actually
Yeah.
have to go through the process of making an educated guess.
Yeah, and without the lights, it's really dark in here. And then if I go back in here, I can guess again. Yep.
Wow.
And that's the game.
Fascinating. That is so It seems really fun. Seems like a really fun game.
Yeah, I think Cameron and I were playing it together yesterday. It took us like 20 minutes to figure it out that time. But we realized there are a couple strategies. It's like finding four-door and dead-end rooms are really informative. And
Okay.
if we had remembered to bring the cube and the painting, we would drop those as like markers of like starting rooms. And then like if we
Uh-huh.
be like, okay, we're back here. I think I know where we are.
Okay. Okay.
And then if we had had more time, we were originally planning on making like some puzzles. Like that could like you enter a room and then the doors lock and then you have to solve the puzzle before you can unlock the doors. But
Yeah,
unfortunately,
and it's also another easy extension, or not easy extension, but another extension is to have some sort of enemy that roams the maze, and the goal is to not get caught.
Oh gosh, that would make it.
yeah, it does
You
get
could quickly
really-
make this game very scary.
Yeah, and
Yeah.
that would even more like having the red orb then is even like more terrifying.
Yeah, there are actually a lot of ways to make this really terrifying really quick. I figured out.
Yeah.
Like when we made the music like slightly scarier than it is now, it got it's really amplified in the like every single room is the same. You're like alone with this little orb.
That's a little claustrophobic.
It's a really clever use of two completely different modes of interaction.
Yeah, I think it's a pretty good. And this is like my first experience really using Unity, and I'm very impressed with how much I was able to do given my knowledge.
Yeah, for sure.
Okay. Do you want us to like walk you through all of the code that we have, or?
Well, you don't necessarily have to walk us through the details of the code. Maybe could you clarify sort of what is the PIC microcontroller doing, and what is there are essentially two CPUs. There's the PIC and there's Cameron's laptop, and they're communicating through this convoluted Git JSON thing. Could you clarify what's the stuff that's happening on the PIC, and then what's the stuff that's happening on the laptop?
Sure. So if we go to the remote desktop, and I'm going to try to do this in VR, so I might look pretty silly, but that's okay. On the PIC side of things, we're generating this maze, so we can see that code up here at the top. We have a struct, a custom struct, that stores information relative to the relevant to the maze. So that's things like whether or not each of the cardinal directions has a door on that side.
Okay.
A position, so like an XY, with 0 being like no, like the very left, and maze size being the very right room. And then we have an is connected and an in maze, and these two are used when we generate the maze. So when we use Prim's algorithm, we essentially pick a random room, get all the neighbors of that room, so the 4 neighbors, pick a neighbor at random, connect it to the maze, and then we get all of that new node's neighbors, add them to our list of neighbors, pick a random neighbor, connect it to the maze, get all of that node's neighbors, repeat until you have a maze like what you see on the PIC.
Okay.
And this will always generate a perfect maze, as we mentioned earlier, which is a maze where you can get to any room from any room. So that's one of the main things that the PIC is doing, is making this maze.
Mm-hmm.
And this was a lot of work, I think. I mean, it took us a week or two to get this working with all the pointer nonsense. The second thing the PIC is doing is drawing the maze on the screen. So we have a function that takes our double array of maze nodes and uses it to draw the maze onto the screen. So it goes through each of the maze nodes and it draws the walls relevant to what the maze node looks like. And then the third thing that the PIC is doing, sorry, what were you gonna say?
I was also going to say we have the end drawing, and actually we could comment out the part that, or I guess uncomment the part that draws the start. For a while we had the start drawn in there too, just for debug purposes. But yeah, it also keeps track of it chooses like a random point on the maze as a start, and then the end point is going to be where it finishes as it like goes through the algorithm, the last node that it assigns to be like a part of the maze.
Okay.
So that usually like keeps them pretty separate. And like make sure that there's like a relatively interesting path between them.
Uh-huh.
Yeah, and the last thing that the PIC is doing, the third big thing, is sending the maze over serial to the lab computer. So the maze we kind of took the serial thread that you guys had written that we used in the labs, and we kind of tweaked it and altered it to fit our own needs. So we have this check for a certain character, like that's how, like you guys did with the button threads and the list box threads. And it will send, when it gets that character, it will send that command to this function, which will process the command. So it will take each of the maze nodes and package them into like a serial packet right up here. So it's kind of an ugly line, but we found that this worked the best. Just doing a big %, and then printing each of the things. And it will send that to the lab computer, and the lab computer will receive all that, turn it into its own class, and then package that into a JSON.
And then each node also has a field if it's like the start or the end that it checks here. And it's literally just like, if it figures out that when it sends a single node, if that is the start, it'll pass a 1 there. And then for the end, it'll pass a 0.
Okay.
And then like so on and so forth. And then in the Python script, we basically like parse this information and then package it into a JSON. Do we have the Python script up right now?
I think I can pull it up. Let me just get the keyboard. I'm
Yeah.
like half blind right now.
You're good. So like in the sequence of the game, the user indicates that they want to start making a maze. We send a command over through the GitHub Python nonsense. PIC makes the maze, sends back to the Python what the maze is. It packages it as a JSON. The JSON is sent to the GitHub, and then the GitHub takes the JSON, sends it to the Unity. The Unity parses the JSON and then turns it into the maze that you see.
Yeah. So here you can see our custom class, which is essentially a mirror of the one on the PIC.
Right.
And then you can see here, while the maze has not been loaded, we continually pull the repo so that we can check for the maze to be loaded. And when we see that the command has become make maze, like you saw in the Windows shell, then it will send to the PIC the command to make the maze and also send the maze back over serial. And then once the maze has been received, right? So we're checking the serial buffer. Once we see we have information in the serial buffer, we package that into our node class. And once we get this 77, which is the last node in the maze, then we use a Python library to turn it into a JSON, print the JSON to the serial, or not serial, sorry, print the JSON to the command prompt to debug, and then we write it to a file and push it to Git.
Okay.
These things down here are some old code for doing debug messages. We have a custom debug things that we can send debug messages with our serial protocol. And yeah. And then if we want to move to the Unity side of things, the script that pulls, I guess I can pull it up quickly. It's not too complicated. This guy. So this is pretty similar to the one that you saw on the lab computer. But it's a lot simpler. So sorry for the no syntax highlighting. I don't have like a editor open.
No worries.
If you don't have a valid maze yet, you continually pull. And then once you see the valid maze, or once you see the command.txt file has been written to not none to make maze by Unity, you push to Git, and then you wait for the valid maze. There's another text file called valid that you check, and when that's 1, then you know the maze is ready, and Unity will pull it in and create it. And that is done. I guess that's like the most relevant Unity script. The rest of it is like how to get the doors to move, how to get the orb to glow. So let me pull up that one, which is maze gen.
I just thought lighting was surprisingly difficult too.
Yeah, the lighting was pretty janky. So again, sorry for no syntax highlighting. In the interest of time, I'm not going to open VS Code because it takes forever.
No worries.
But essentially here we're passing in a bunch of game objects, things in the game that we want to move around, right? Because the starting room starts in one area and then we want to move it somewhere else when we've picked the starting location. Essentially, this is going to, so there's an update function, and the update function is something that's called by Unity. It's called once per frame. So every frame this function is called. And it's going to wait for gen to be set to true. And gen is, you remember the button I pressed in the beginning, gen is, when that button is pressed, gen is set to true.
Okay.
And then once that's set to true, it will call this create function on the JSON. And the create function, essentially, we have what's called a prefab, which is if you were to take this starting room and put it into a box and store that box somewhere where you could take copies of that box, that would be a prefab. So each of the rooms that you saw us go through are part of a prefab, where each prefab includes an empty wall and a wall with a door. And then we create as many prefabs as we need to fill out the maze. And we go through the node list, as you can see here, and check each of the directions. And if the direction is true, meaning it has a door, then we enable the component that is a wall with a door and disable the component that is a wall without a door, and vice versa. And then down here is where we move all of the things that are in the starting room, like the starting room itself, the sphere, the painting, the cube, to the proper location of the starting room. And that's how, that's really like the main Unity script. All these other scripts, like the elevator move and the elevator door, are all things like the doors opening, pressing the buttons, checking the end of the maze. And they're just like game things that make the game playable.
Yeah. I think in the interest of time, I think we're pretty done. Are there any other questions that we should answer?
Not for me. There's so much going on here. It's really an impressive demonstration. I mean, the amount of infrastructure building here is unreal for a 4-week project.
I would say that we spent the first 2 weeks doing the maze generation and kind of mapping out our project. The third week doing the infrastructure, and the fourth week doing the Unity things.
Okay.
Yeah. I think we definitely realized how much planning it took to like.
Yeah, we have a lot of.
I think we spent the
random
first
documents.
2 or 3 lab sessions just writing documents to like plan out how we were going to do this, and then throwing them out and then re-editing them, and yeah, it was a lot of fun.
Yeah, it was a good time.
I mean, you sounded like you were having fun when you did it. You'd come in and you were laughing about the orb falling and stuff. It sounded like it was good fun. It also strikes me that this is a kind of a novel use for the distributed environment we're using this year.
Yeah, I think it was pretty good. Like that quarantine game type deal, a game you can play across the world potentially.
Mm-hmm.
Right.
Yeah.
Right. Well, excellent. Thank you all so much. This was a really, really cool demo.
So, okay, thank you.
Thank you.